Right now, as you sit watching this, you are being dragged through space at 600 kilometers per second. You might feel completely stationary, but physics says otherwise. Earth spins on its axis, orbits the sun, and our entire solar system circles the center of the Milky Way galaxy. Zoom out even further, and the universe itself is expanding. Under the normal rules of astrophysics, every galaxy should be drifting away from every other galaxy at a relatively even, predictable rate. But that 600 kilometer per second drag defies the standard math. It is a peculiar velocity, an extra layer of movement that directly fights cosmic expansion. An unknown force is overriding the basic mechanics of our universe, pulling us in. The first hard proof arrived in the 1970s. Scientists were studying the cosmic microwave background, the lingering radiation left over from the Big Bang that permeates the universe. This thermal map shows a stark contrast in the radiation. One side of the sky appears slightly warmer, while the opposite side appears cooler. It is a cosmic Doppler effect. Just like the pitch of a siren changes as it drives past you, the light ahead of us is compressing and heating up, while the light behind us is stretching and cooling down. This temperature gradient confirmed that our entire local group of galaxies is moving together, hurtling in one very specific direction, straight towards the Centaurus constellation. But when astronomers pointed their telescopes towards Centaurus to find the source of this immense gravity, they hit a wall. The object pulling us is situated perfectly behind the thickest part of our own galaxy. Scientists call this cosmic blind spot the zone of avoidance. Our Milky Way is a flat disk, and because we sit inside it, looking outward towards the center means trying to peer through billions of stars, thick gas, and dense dust. This cosmic debris completely blocks visible light from about 20% of the night sky. We were left with an unsettling reality. Our galaxy, and thousands of others, were falling rapidly toward a gravitational titan, and our own cosmic shadow made it completely invisible. For decades, the anomaly remained a ghost. It took a technological shift in the 1990s to finally break through the dust. Instead of relying on visible light, astronomers turned to radio waves and infrared technology, which can pass cleanly through the Milky Way's debris. Instruments like the Parkes Radio Telescope in Australia scanned the zone of avoidance and uncovered a massive structure hiding in the dark, the Norma Cluster, a sprawling collection of thousands of galaxies. This location, dubbed the Great Attractor, is a dense focal point where multiple massive galaxy clusters converge, holding the mass of tens of thousands of Milky Ways. Despite its scale, the Great Attractor lacks the gravitational muscle to account for our total velocity. Calculations suggested a much larger force was still missing from our maps. The true scale of our cosmic neighborhood didn't come into focus until 2014. By mapping the velocities of over 8,000 galaxies, researchers discovered we live inside an unfathomably large supercluster named Laniakea, home to 100,000 galaxies. Laniakea acts like a cosmic watershed. Like rain flowing down a mountain, galaxies stream along gravitational tendrils, pooling toward a single basin. The Great Attractor is that basin, the deepest valley in our local universe, where everything is flowing. Yet, even when accounting for the total mass of Laniakea, the numbers still fell short. The math clearly showed that something else was heavily influencing our velocity. The answer lay another 400 million light-years past the Great Attractor. There sits the Shapley Supercluster, a structure first hypothesized by Harlow Shapley in the 1930s. It is one of the largest mass concentrations in the known universe, and its immense gravity is actually dragging the Great Attractor itself. In 2017, researchers identified the dipole repeller, a colossal, empty cosmic void located directly behind our galaxy. Because it lacks mass, it acts as an active repulsive force, pushing us forward. We are caught in a massive cosmic tug-of-war. The Milky Way is flowing down a gravitational valley toward the Great Attractor, while simultaneously being shoved from behind by an empty void and reeled in by a distant giant. With all this momentum, with so many forces pushing and pulling our local group, you have to ask, when does the ride end? When do we crash into the Great Attractor? The answer is never. We are witnessing a war between local gravity and universal expansion. This diagram shows the nodes of the cosmic web trying to pull matter inward, while an underlying force called dark energy rapidly stretches the very fabric of space, forcing everything apart. Right now, gravity is winning locally, keeping our immediate neighborhood intact. But dark energy is accelerating. Given enough time, it will overpower the gravitational bounds holding the Laniakea Supercluster together. As that expansion continues, the Great Attractor and the Shapley Supercluster will be physically torn away from us. They will recede faster and faster until their light can no longer reach us, fading completely into the invisible void. Dark energy is the undisputed victor of the universe. Eventually, our local group of galaxies will merge into one massive star system, drifting alone in total darkness, with no other galaxies in sight. We exist in a highly privileged window of cosmic time. We are the lucky few who arrived right when the sky is still illuminated, allowing us to map these invisible titans and chart our course through the dark, before the universe erases the evidence forever.